Today's demo of the Nlyte software solution is going to start. I'm going to give the briefest of brief high-level overview of Nlyte software, the company, just so you know where we're coming from. Then I'm going to turn the controls over to Steve Hake, our sales engineer, who's going to show you the actual live application. And please feel free to go ahead and type your questions into that question pane. I will keep an eye on them and interrupt Steve to say, hey, we got a question here. And with that, let me breeze through a couple of quick slides on the company. So Nlyte Software is a dedicated software development and software publishing company that is dedicated to the proposition of improving the operations of data centers. And what we do is we model your data center in a centralized database. That's what you're going to see a demonstration of today. And the results of what we do is we, and what I'm showing you here is some of the companies who we help optimize their data centers, and include some of the largest and best run organizations in the world. We have over 160 customers now. And our customers are satisfied and come back and renew their software licenses with us because they find a lot of value in this data center infrastructure management solution. Our customers range from very large organizations down to medium-sized enterprises. And one of the things that drives this value that people using Nlyte software are able to see is all these changes and pains in the data center. It's a dynamic environment, and it's getting more complex over time. And data center managers have to deal with increasing power and heat density, data center consolidations, data center infrastructure moving to the cloud, as you can see on this slide. And that's what Nlyte software is dedicated to helping you solve. So our solution helps data center managers improve efficiency, defer the build out of new data centers by making that data center, your data center, more efficient, asset lifecycle management, energy efficiency, just like you can see here, also compliance issues. This is my last slide before I pass it over to Steve. It gives an overview of how the Nlyte solution integrates with other parts of the data center world by taking in inputs from data center equipment, the IT organizations, also the facilities organizations, and then bubbles those up into enhanced business decisions because you're able to visualize your assets, analyze them, and manage them better. So that's the broadest of broad brush overviews. And Steve Hake, I am going to pass the program over to you. Hold on. Change presenter. Steve Hake. There you go.
Okay. Yeah. Show my screen. Should be able to see the application now. Okay. Excellent.
Yep.
So this is the Nlyte application. It is a web-based application. So all the functionality we'll look at today will be through browser and accessible via role-based access control, turn on or off feature functions that you want different users to have or not have. I brought up a view of a data center room. In the demo system, it's called the Blue Room, where I'm looking at rows of cabinets, some cracks, and PDUs, as well as user-defined areas. So this room is organized by pod. That's because that's the way this user defined their organization. You're free to label these areas for whatever purpose. In addition to the pods, down here in the checkerboard, I have an area that's dedicated to the network team. These can then be used for targeting deployment of equipment as well as reporting and other subclasses within the data center. I asked to see this room from our location picker. So our larger organizations that use Nlyte will have tens of thousands of racks under management. They'll use a single instance of the application to manage multiple data centers, coordinate activities worldwide. When I ask to see a location such as the blue room here, the tool goes out to the database and loads this view for me based on the latest information. It's a collaboration tool, so if somebody was planning decommissioning or adding of new assets, I'm going to get a current view of my data center, as opposed to prior to Nlyte, a lot of large organizations were trying to do this type of work through a spreadsheet or a AutoCAD or a Visio, tools that weren't designed to do lifecycle management, weren't designed to be a collaboration tool. On the left, I see a navigation bar. There are many things I can do, such as BL-02, for example, is the name of a cabinet. When I select that cabinet, I can see the location of that system in the data center. If I need to, we understand all the data that's behind this, complete network chain, power chain, as well as rack elevations. And here I can see, by expanding on the BL-02 cabinet, the assets that reside inside of that cabinet. There's some patch panels, some storage, and some servers. And then there's one level more that I could expand on the servers to see things like partitions, physical or logical virtual machines that are running on a particular system. This information and this view and other views within Nlyte quite often is turned over to service management teams for the purposes of identification of problem resolution. If I were working in the service management team and needed to identify the location of a server, for example, I could quickly locate that within a room. I could have access to this information in a view-only mode, so I wouldn't be allowed to modify it. For the people that are working with the servers, they have information at their fingertips, such as are there any virtual machines running on that system? Perhaps I'm targeted with decommissioning a server, and I can validate that all the virtual machines have been removed from that system before I decommission it. All of the data that we're looking at here is stored within the tool on layers. It's also a lifecycle management system. So when I'm planning the new deployment of a pod or a row of cabinets, whatever the case may be, I can drag and drop that onto my drawing to reflect that. In my demo system, I have a number of layers defined to hold different components. An example of a layer that's currently turned off is cable trays. So depending on the information I need to access, I could turn on or off a layer as needed based on querying of the information. Layers and what's defined and maintained on them can be added and renamed within the tool. There's also quite a bit of reporting throughout the system. One area where I see reports is in the overlay in the floor plan view that we're looking at here, where I could ask for business-related metrics. Show me all the groups using the different cabinets or business teams. Let me see availability of capacity within the data center, copper, fiber, port availability, power by phase, consumption and availability, remaining cooling capacity, rack space capacity. All of that's available to me for planning and reporting purposes. So simple example, I'll ask to see the cabinet U space. I'll apply red, orange, green, this regular scheme to that, and then I can quickly see which cabinets still have space in them, which ones are consumed. Going back to this user-defined network cage area, I can see that all of my communications cabinets are near full capacity. If I were going to bring in a new Cisco switch or whatever that needed to go into those cabinets, I need to order additional capacity before I could do that because my cabinets are full. All of the data within here is stored and maintained very specific levels. When I look at a particular cabinet, BL-74, which currently has 20 rack units of space, I know very detailed level to the millimeter or inch, depending on my preference, where that cabinet is within the data center. So all of this information is very specific and detailed. Another report that I'd like to show, maybe a different use case, is around remaining cooling. And here I'm not looking for a hotspot, so I'm going to apply a different scheme. But what I want to do is check my data center and make sure that I've done a good job of balancing the cooling requirements, the demand in the data center. So this is an as-modeled view used for planning purposes. I can see that I've done a really nice job of balancing out the cooling requirements. I haven't created hotspots where I'm going to have failures. I can run my data center at a more efficient, higher, more efficient temperature without concern of creating hotspots. We have within the tool a patented methodology that says based on the attributes of assets, things like servers, storage, components coming into the data center and their requirements, and the capacities of the data center, recommend locations of where to put the equipment that can accommodate it. We take many factors into account. Is there space for the equipment? Do I have power? Do I have the network connectivity that equipment? Am I okay on weight constraints? And this is showing another parameter that's taken into account, which is balancing out of the cooling requirements. So doing the life cycle management, optimizing the placement of equipment, and realizing these type of efficiencies is one of the value propositions from the tool. Other reports I can see in the floor planner would be in statistics type of summary information. So here I'm clicking on the entire floor. I'm going to narrow it down to an individual area, user-defined area, in this case pod 5. I can see the space that's been allocated to that area, as well as a heat and weight gauge. The heat and weight gauge are showing me for user-defined thresholds in those areas, how am I doing against the capacity. In the heat gauge, I see 3 bars. The left bar in blue there is showing me based on real-time metrics collected for that area, and then the yellow and green bar are as models. How is my consumption of heat and cooling capacity against the thresholds for that area holding up. And then the bottom right, I see the similar type of thing based on weight. For the weight loading characteristics of that area and the equipment I placed in there, how much remaining capacity do I have? I'll pause here before we move on and look at some other asset and elevation views. If you have any questions, go ahead and type them out for Marjorie. All right. So what I'm going to do now is look at the elevation information behind this view. I'm going to select 5, 6 cabinets there that are in a row and happen to be next to one another. If I wanted to, I could pick 2 cabinets that were in separate areas or separate data centers, maybe my primary cabinet and its DR sister cabinet and a DR site, and do a side-by-side comparison. So I can either do this physical view that we see here or a logical comparison. In either view, on that similar navigation bar to what we saw in the floor planner, where I could quickly identify the location of a server or potentially what virtual machines, in this example, are running on that server. Like the floor planner, I have many overlay reports that I could run. An example here, maybe I want to see the real-time power consumption for the different pieces of equipment in my cabinet. Now, if something was off here and I had an asset that was consuming more power than I expected, of course, I could select that individual asset and then ask to see detailed information here. I'll show you that asset view in a minute, but before I do that, I want to show another elevation view, which is our cabinet planner, that has similar information, an elevation view of the equipment in that cabinet. This is a 3D representation, so I can determine, is it practical to put a component, maybe a shallow component, both in the front and back of a cabinet, same rack unit. We see other items I'll point out here, things like markers, areas reserved for airflow, as well as cable management. At the cabinet level then, we have a heat gauge, summary consumption against the thresholds for that cabinet, as well as the weight gauge. Other information that we're tracking within the tool would be the complete network chain as well as power chain. And in the cabinet planner view here, one of the things I can do is ask to see port information as opposed to the images that we were looking at earlier. So here, asking to see port data at the cabinet level, I can see a patch panel, how many ports are currently consumed, how many ports remain available, and then if I select any of the individual ports, I can see connectivity data behind that. This particular port on the patch panel is going to a particular server, and then right here I have more detailed information. What's the source asset, source port, destination asset, destination port, cable name, cable color for that. So we're tracking all that physical port connectivity, cable connectivity, both for the network and the power side, and I have that visibility for that here in the cabinet planner. Now here I'm going to select a C7000 blade enclosure. In the cabinet view on the right, I have detailed information for that as well. I'll point out that I could ask to see connectivity information. I'll come back to that later. But here I'm going to go ahead and select that asset to look at the asset detail for this particular record. This is an asset information within the Nlyte system. Asset data, in this case for a C7000 blade enclosure. In the upper right here I have simple as well as advanced search capabilities. So the simple search, I could enter a name or a wildcard name and arrive at a list of assets that I was interested in. Within the solution, we track things ranging from air conditioning to UPSs. Storage is considered a peripheral, and virtual machines are considered a host. There's quite a bit of assets that we track tied to the data center, obviously. In addition to a simple search, I can do an advanced search where I and conditions together. So many of our customers will leverage this capability to do more complex searches where they'll say, show me all the systems from a particular manufacturer, maybe all my Oracle systems at a particular location that are coming off of lease next quarter, so I can start to plan my tech refresh. So I can very quickly query the tool based on conditions like that, and then leverage the output for planning purposes. Had I started at this asset record, I could quickly navigate back to the cabinet view, the floor view that we started with. So in the lower right here, I can see what cabinet does this system reside in, what room is it in, and I could ask to see the blue room there. So very easy to navigate back and forth. There's also quite a bit of information on the left about this asset. And we have integrations with tools like HP's UCMDB, where we can bidirectionally exchange this information with the CMDB and leverage discovered technology as well to populate or exchange information that's shown here on the left. So some of the things I'll highlight would be support. Who do I contact for support of this equipment? Ownership, maybe a similar use case. What's the business group or technology team that owns this equipment that needs to be notified if there's something wrong with it? Some customers will also leverage this type of relationship for purposes of showback or chargeback, because we understand the consumption of this component. And in the data center, the one thing most people care about is power and cooling. I can go back and run a report and go back to the business owner and say, here's how much power your units in our data centers are running. Are there ways we can reduce that cost? Maybe it's a virtualization or a replacement of older systems with newer technology. But our customers will leverage this type of relationship for that showback, chargeback purposes. Because this is a blade enclosure, we understand what's inside of that system. Where do I have available slots, in this case showing up in green, as well as what slots are occupied by full height and half height blades. On the back, then I also see open communication slots as well as slots that are occupied by onboard administration, as well as fiber and copper communications modules. Further down the list, I track things like what's the warranty for this system, when was the last maintenance performed on the system, and then at the bottom here there's a notion of custom fields. So if there's an attribute that you want to add that we didn't think of, you're free, very easy for end users to go in and add a custom field. Those can be searchable items then as well in the advanced search. I'm going to select a blade from this. I'm going to select a server blade from that chassis, bring up a server record, server asset record within Nlyte. All server records, whether they're floor standing, rack mounted, or in this case inside of a chassis, will have a similar look and feel. There could just be different information as far as where is that asset mounted. Here I can see similar information, views at the blade level. Other items that may be of interest here to track would be things like what virtual machines or physical partitions have been created on a particular server. And then if I select the host record here, that would yet be one more level of asset within Nlyte. So all these rich relationships are supported. And then at this level, I may care about things like what applications are running on the system. Again, so the person that's working in this area for their domain expertise has some level of impact analysis. If I take this system down, I'm impacting more than the physical system. I'm impacting these applications or these virtual machines that are currently running on that system. I'm going to close a couple windows down here, and we'll go back to the chassis view, and I'm going to ask to see connections. So like we saw in the cabinet planner, we understand connections, and this is another way I can look at that type of information. Here I'm currently looking at level 1 of information centered on my C7000 blade enclosure, and I see a lot of green connections, which are power connections. So I've got 3 cords plugged into one power strip or a cabinet PDU, 3 into another cabinet PDU, and then it's providing power for the blades and modules inside of that chassis. Now I could ask to view details instead of the icons that we see here, organize things by location. I'm going to ask to see the entire power chain for this blade enclosure. This is as modeled in my Blue Room. I see that for the power chain that this unit's connected to a couple of power strips, which then go to whips or receptacles in the floor. These big units are the PDUs that are then connected to those, ultimately the power strips. And these are assets within Nlyte. If we opened up those asset records, we'd see the individual panels and breakers that are connected downstream. At any level in the power chain, I understand and can see consumption metrics. What's the current power load, remaining available power, and by phase at the PDU level is shown in the upper left there. As modeled, this goes back through a couple of UPSs and then to a switchgear in that data center, running that data center room. We use this information for a couple different purposes. What if impact analysis? We know what's connected downstream to this PDU. If I take it down for maintenance, what's impacted by that maintenance? The opposite. When I'm deploying an asset into the environment, like a new C7000 blade enclosure, we can make sure it has sufficient power in the location we're targeting, as well as for equipment that supports it, redundant power, as we see modeled here. So we use the information for impact analysis as well as planning purposes when deploying new equipment. I'm going to go ahead and turn off the power chain, and then I'm going to ask to see a couple more level of information out with leaving power and network checked. So this will bring up a lot of detail around network connectivity in the data center. So now I see fiber connections in blue, copper connections in orange, and I have a level of detail that tells me for a module inside of my blade enclosure, is a port on that module is connected to a patch panel. Behind that is structured cabling. Patch panels patch panel connectivity. And at each of the connections, same information we saw in the cabinet detail. What's the source, destination, asset, destination port, cable name, cable color. Using this information for the same purposes as power, impact analysis, what's connected to what, as well as when I'm deploying a piece of equipment, do I have the available ports? Do I have the connectivity that I need? Another way customers will leverage connectivity trace information is around troubleshooting purposes. So in this case, I'm looking at a server, which is a rack-mounted server. Within the system, we know the detail of what cards reside inside of that server. So in this case, I see inside of that server, I have a HBA and a NIC card. One port from each card is connected to a patch panel. And I can see that relationship here within the table view. But I can also ask for connectivity trace centered on that card. And I may use this for a different purpose, one of troubleshooting. I have a NIC that's failing. Is it a cable that worked itself loose somewhere in its connection, or is it something wrong with the server itself or the NIC itself? So here, centered on this server, I can see that that individual connection makes several connections through patch panels, ultimately arriving at a module inside of a Cisco chassis. And again, at each of the connections, I understand the details of what's the source port, destination port, and I could use that for tracing the cable connectivity and troubleshooting purposes. I'll pause for a minute and see if you have any questions before I move on to the next example. What I'd like to do then is walk through a simple use case of lifecycle planning. In this case, I'll say I've got a new server coming in to the environment. It's a DL360 from HP, and I want to plan and reserve the space for that system. So here, our list of, I searched our material catalog. We provided a history of definitions, and we're constantly updating it with new definitions around the requirements for a particular server. It's also very easy for customers to create their own definitions. In this example, I'll say I've got a DL360 G7 server coming in, and I want to plan for the deployment of that equipment. Now, based on this Nlyte supplied definition, I know the dimensions. I know this goes into a 19-inch rack, takes up 1 rack unit of space. I also know, according to the manufacturer, HP, it'll consume 1.2 kW of power, and I've overridden that to say in my environment I should plan for 0.76 kW of power. I also know that this equipment has 2 power cords, and during normal operation it'll draw equally from both cords, but it can run, if it lost source of power, it can run from a single power supply. It does support redundancy as well. So leveraging this definition, I'm going to create an asset record, and I'll call this VSH111 server, just a name for that server, and assign it a state of pre-procurement. Now I have a record for a system that's still in a planned state, but I can go ahead and account for that in my data center. I'm also going to go ahead at this time and say when the system comes in, I want to account for a copper connection and a fiber connection. Now I'm adding generic cards here. I could be more prescriptive and say it's a ProCurve or a Cisco card, whatever the case may be. Based on this information, if I knew explicitly put in cabinet BL-02 for whatever reason, I could do that. I'm going to use that patented methodology that I talked about earlier to recommend locations, best fit locations for this equipment. So here, this screen is blank because this is a net new piece of equipment, but just like we're managing the deployment of new assets, we also manage the move, recycle, and decommissioning of equipment. So for those actions, if I were impacting a change of another component in my data center, I'd see those relationships here. Now, on this screen, I'm going to target the blue room, the room we were looking at earlier. I could target another room or a user-defined area within there. And then here's a list of criteria that I care about when deploying the equipment. I want to account for the space, the power, the cooling. Cabinet usage is a user-defined field that you're free to define. If you allocate certain equipment to certain cabinets, you can then have a cabinet usage and target the deployment of that equipment. A common use case that I have amongst a number of customers is they'll target equipment that supports legal applications for cabinets designated to the legal groups. In this example, I'll go ahead and say this equipment could go into any cabinet. I'll exclude that criteria. I know I don't need a KVM. I do want to account for the diverse power. I do want to connect up to the network connections that I identified, but I'm not looking for a particular IP address. I'll unselect that. So based on those criteria, Nlyte comes back and says all of these cabinets can accommodate that equipment. We'd recommend, for the purposes of balancing out the cooling requirements, placing it in cabinet BL-106. I'm going to go ahead and pick a cabinet a little further down. I see that it has some space that I want to place that equipment in. So I'm picking the cabinet now. Based on this selection, Nlyte's putting that asset that hasn't arrived yet into that cabinet. It's gone ahead and connected it up to the power chain. It's connected it up to the network for me. If we look at the cabinet planner for the targeted cabinet, we'll see here in the scratch pad that that new system SH111 is targeted for this cabinet. I could specify an explicit rack unit to place the equipment in. We've also gone ahead and created a work order. So when the equipment does arrive, the technician can reference a document online that says, place this equipment in this particular cabinet, connect it up to these network ports, connect it up to these power outlets, this document helps our customers get the installation correct the first time. Because this has been planned to be targeted for that deployment, we're also avoiding conflicts. The next person that comes along and plans a deployment can't take the space, the power, the other resources that I've reserved. I'm going to avoid conflicts and oversubscribing to resources that would provide, potentially result in failures. With the remaining time, I want to cover a little bit of our reporting as well as our workflow tool, unless there are any questions on what we've looked at. All of the data that we've looked at up to this point is stored in a performance database. We mine that. Yep.
Hey, Steve, we have a question.
Yep.
And the question is, can you do this on a cabinet level?
Yes, so we have the ability to create templates. So much like I showed a deployment of a server, we can do that for a cabinet. So if you had a predefined cabinet that was going to look like something, have these servers in it, you could select that instead of the server. That even extends up to the pod level. So you could say, I'm going to bring in a number of cabinets that represent a common order, and instead of starting at the server level, which I did for this example, you could start, use the templates to represent a cabinet or a pod. The data that was, that we've worked off of up to this point is stored in our performance management database, a SQL database. We're also mining that data and storing in a business intelligence engine. We have a rich set of analytical as well as dashboard views that work off of the business intelligence engine that allows us to look back in time and do rich historical reporting and trend analysis for the environment. There are many reports that ship out of the box. You can see on the left here, all of these reports would be standard reports with the tool. reports as well as dashboards are designed to be customer extensible. So I have a folder here where I've created some additional reports. I can take an existing report, make a modification, and then or write a brand new report, and then I store my reports in the user folder here. A couple of examples of reports. Real-time power. This goes back to that showback or use case, chargeback use case I mentioned earlier. I say for a particular customer in a particular location, here's a cost per kW to run the equipment, and then based on the equipment and the real-time metrics that we've collected for that user, here's their average daily power cost in the environment. Example of another report would be a cabinet capacity. Let me narrow it down to an area. I'll look at the blue room. Show me measurements for cabinet capacity, space, power, as well as network connectivity, cabinet usage against thresholds that have been set in the environment. All of the reports can be exported to multiple formats, Excel, Word. They could also be scheduled to be emailed to somebody on a regular basis. There are many forecast reports that work off of trending data. An example of that would be the heat cooling history forecast report here, where I could do something like, say, the blue room. Let me see what I've been doing over the past 6 months, and then, this report says if I continue along these lines over the next 12, 24 months, here's where we'll be in the data center, and our customers can leverage that to look at capacities in the data center and either change the direction or estimate when they're going to need additional capacity based on different metrics, weight, heat, port consumption, are all have trend type of reports. Similar to the reports, there are 12 dashboards that would ship out of the box, designed to be customer extensible as well. We're looking at an operational view here in the dashboards. Now, in this case, I went back and I'm looking at a date that's over a year old. So we've got all this historical information. I didn't narrow my search down to a particular location. I could have said, show me the blue room or an area. In this case, I'm summarizing all the data centers that I'm managing in the tool. And then I haven't applied a project yet. I'll come back to that. That's how we do what-if impact analysis. But here I can see space, power, cooling, and network metrics on the dials. What is my asset breakdown? How many moves, adds, changes, as well as workflows have I run in the tool? And then some details here about each of the locations in the current utilization table. Now, projects within Nlyte could be many things. They could be committed projects, a tech refresh, data center consolidation, a new project that the organization is committed to where instead of going one-off, I maybe need to deploy 10 or 20 new servers to support a new initiative. And I can commit to those projects and then reserve the power, space, cooling on a project level that we saw earlier on the server level. Projects could also be forecasted projects. The company is thinking of a new initiative or several new initiatives next year. I haven't been committed to yet, so we're not going to reserve the power, space, cooling, etc. But we want to do what-if impact analysis. If we went ahead with one or more of these projects, would we have capacity, and what would be the impact of moving forward with those projects? So here I'm going to ask for the impact of a Q3 migration forecast project on my data center environment. I see the capacity requirements move a little bit within the dials. I'm still within an acceptable range. But more importantly, I know if I moved ahead with this effort, I would need an additional 400 kW of power. So this allows our users to go back maybe to a business owner or the team thinking about this new project and say, you're taking many factors into account when estimating the cost of this to the business, but we ought to factor in, the cost of an additional 400 kW of power, so they can be very precise in their modeling and justification application of new projects. There are other dashboards that would have more detailed views around asset data, cooling capacity, power capacity, as well as metrics around workflows. So using the tool to manage, move, add changes in the environment, our customers can go back to their customers and say, are we meeting the SLA? Are we meeting the agreed upon time that we have to maybe deploy new equipment in the data center, or whatever those appropriate tasks are. An example of a more detailed dashboard, if I click on the space dial there, I will get detailed information. Use space capacity, what's the trend line been for consumption of use space over the past 6 months? Quite a bit of information around fragmentation. Can I handle new, larger systems that are coming into the environment, or do I have a lot of space that's tied up in one U areas? Who is consuming what capacity across the organization, as well as more detailed information by cabinet. The last thing I'll cover briefly here is our workflow capability. So we have a workflow tool. This also integrates with change management systems such as HP's service management system. Our customers, prior to adopting Nlyte, it may take them, I'll use new deployments as an example, 30+ days to deploy new equipment into the data center. During that time, the equipment's depreciating. Quite often, equipment coming in the data center is targeted to replace old equipment. So during that time, 2 pieces of equipment will be running in parallel. By modeling the individual tasks that make up the larger request, maybe deploy new equipment, assigning that with an SLA to a group or individual, and being able to coordinate and prioritize work, they've been able to reduce that time from 30+ days to a week or less, and realize significant savings from doing that. We provide the workflow tool that allows customers to model their tasks. This is the designer where you would update or model your task. It's a drag and drop interface. So the design we're looking at here was done around a new asset deployment. In this case, the customer had a request coming in, which was originated by their hardware team. They have a group that would first approve or not approve the request. Assuming it's approved, it would go then to a team that does the space or rack allocation for that equipment. It would then go to a team that does the electrical assignments. And then there's a couple of groups here that can do their work in parallel on the network and SAN teams, and then additional steps through to completion. If the request was not approved, it would go back to the originator to be fixed, and then come back again for approval. Now, if over time their process evolves, they can simply go back to the design tool. If they needed to add a new step, for example, between the space and the electrical team, they could define a new activity, assign that to the appropriate group, have an SLA associated with it. And the next time this request is made, that additional step would be taken into account. So very easy for customers to design, create their flows. They might have several flows they work off of, one for deploying equipment, one for moving, one for decommissioning equipment. We also, as I said earlier, integrate with tools like HP Service Manager. So I might have a couple points where I want to integrate my flow with a tool. When I get to a certain point, wait for external approval, and when I'm all done, go ahead and close out the ticket that originated the request. Would be a couple of examples, and I can accommodate that very easily within the workflow. From an end user perspective, if I were a member of, say, this network or SAN team, and it came time for me to perform an action, I would get an email notification. You have work to do, Steve, and then I would be able to go to the different screen within the tool, and I'd be able to see my outstanding work. So here's an example of all the work that's outstanding in the queue. We have a request that's based on that design that we were looking at, and it's currently sitting in the network and SAN teams. They both have open tasks that can be done in parallel, and then I would leverage, this more detail behind this to go in, see the equipment that's impacted. Once I've done my work, I mark this step as complete, and then it would go on to the next person in the queue. So with that, I'll leave just a few minutes then for any additional questions, or we can wrap it up, and happy to follow up, more detailed conversation or more detailed demonstration if need be.
All right, Steve, thank you for that demo. We'll hold on a couple minutes in case our audience has any more questions. Great chance to, oh, we got a thank you. Thanks for your time. So looks like we don't have any more questions. Steve, thanks again for performing the demo, and I'm going to end the session now. Thanks again, everybody.